Hi, this is Ms. Delosier, and these are your notes on convergent evolution and analogous structures. So the first thing we need to talk about is what is convergent evolution. Convergent evolution is when you have independent evolution of similar traits in organisms of different lineages. So what does that mean in English? It means that I'm going to get the same adaptation showing up in distantly related species. I would say unrelated species, except all species are ultimately related. So very distantly related species. So let's look at an example of convergent evolution. The main thing you need to know is that the common ancestor for these two organisms does not possess the trait. And these are frequently results from organisms living in ecosystems that have very similar selective pressures. So if I have organisms that live in an aquatic environment, it might be helpful to be very streamlined. So we're going to look at an example of convergent evolution where you've got drastically different lineages that are all arriving at the same basic adaptation through different lineages, but it's the same selective pressure. The selective pressure is if I'm hydrodynamic, if I'm streamlined, then I'm going to be able to move faster through water. So let's look at the fish. The fish is related to the shark. So the shark has that very hydrodynamic torpedo shape right there, and that's no surprise because it's related to the fish, right? But how about this? This is a land reptile, some early land reptile. So that's my little iguana right there. And the land reptiles, we know, evolved into, one of the land reptiles evolved into the ichthyosaur, which is it's a dinosaur that went extinct about 65 million years ago. But we do know that that came out of a reptilian-like lineage, and if you look at the shape between the ichthyosaur and the shark, they are very similar. They're both very hydrodynamic and torpedo shaped, and I know you guys know what the next one that's coming is. If I look at a pretty generic ancestral land mammal, so ferret-like or large rat-like, the mammalian lineage also has a very similar shaped organism. So the dolphin also has that very similar shape. So here's three different lineages, fish, reptiles, and mammals, and I'm getting organisms out of those three different lineages that all arrive at the same shape. And then the fourth one is if we look at birds, we also see that same torpedo-like shape in penguins. So this is an example of convergent evolution, arriving at the same trait or similar trait through very different evolutionary lineages, and that's due to similarities in the selective pressure. So they are all hunting or living in water, so they all need to be able to move quickly through the water. Now, analogous structures are in contrast to the homologous structures that we've already talked about. Analogous structures are when convergent evolution leads to structures that have the same function. So convergent evolution leads to analogous structures. So they're going to be functionally similar traits, but they do not share a common origin. So the easiest example of this is to look at wings. So here I have a wing of a butterfly, so insect wings, right? Well, we also see wings in some mammals, right? Bats, bat wings. And clearly, not all insects have wings and not all mammals have wings. So the common ancestor between insects and mammals did not have wings. Wings arose independently in insects and in bats. And obviously, it also evolved independently in birds. So that's an example of an analogous structure. An analogous structure, wings, like they're all going to have the same function. They're going to allow flight, right? And they don't share a common ancestor, at least not a common ancestor that had wings. And so what's the the way that those are going to evolve, well, that's convergent evolution. What's the selective pressure? Wings provide a definite selective advantage, a definite movement advantage. So you can see how that's different than when we talked about the homologous structures of the forelimb, where you had the radically different shaped forelimbs. They all shared an ancestor. This is different. Same function, do not share a common origin. That's it for your analogous structures, and I hope that that helps. And if you have any questions, please come on in.